Hi everyone, it's James here, and in this tutorial we're going to do some more challenges on the Edabit platform, but we're going to move past the really basic and simplistic starter questions and move on to some challenges that have got a bit more meat and require you to put a bit more thought into the problems that you're being asked to solve. So let's dive in and start looking at some more challenges on the Edabit platform.
Okay, so in our last lesson, what we did is we actually went through the very easy Edabit challenges, or at least a few of them, and you can see we've got them completed here. But we're actually going to bump the difficulty up in this level so that we're doing something a bit more challenging. And I did take a look at the medium level challenges, but they are quite a bit of a difference from the very easy challenges. So I'm actually just going to go to the easy challenges because there's not so much of a jump from very easy as there is from very easy to medium. Okay, so let's choose those from our drop-down list, and you can see here we've got some uncompleted challenges. And the first one is about bitwise operators, which sounds pretty scary, and I'm going to skip over that one for the moment, but we will come back to that at the end of the lesson just to run through it. But the first challenge we're going to do today is the add up the numbers from a single number, and this is quite a common challenge that's set on a lot of other platforms as well. And just to give you a brief overview of what the challenge is asking you to do, basically you're asked to create a function that takes in a number. And say, for example, if the number is 4, what you need to do is count up all the numbers to 4. So, for example, 1, 2, 3, and 4, and basically add them all together and then return the result. So you can see here 4 should return 10, and 13 should return 91, and 600 is going to return this massive number here. So what I'm going to do, like I did in the previous tutorial, I'm going to take the boilerplate code that they've given us, the function definition, and I'm just going to do this in a really simple way, and then we'll look at maybe a couple of ways that you could solve this that are slightly more complicated. So let's start off. We've got our function and we've got the number being passed in, so we don't need to do anything with that. So what we're going to be doing is keeping track of a running total, which is going to be a sum. So let's create a new variable called sum. And this time I'm using the let keyword to declare the variable because we're actually going to be reassigning a value to this each time. If we were to use const, for example, we're going to run into some errors because we're going to be updating the value that's inside of sum each time. So let's stick with let there. And if you haven't got an idea of how to solve this as of yet, it might be worth just pausing the video and think, well, how would I actually get all of the numbers from 1 to 4, for example? What JavaScript code could you use to actually count up from a certain number to the given number that's provided to us in the num variable? So take a moment to do that, and when you've got an idea in your head, let's crack on with completing this function definition. So what I'm going to do is I'm going to use a for loop to loop through all of the numbers up to a certain value. And the way I'm going to do this, I'm just going to set up a basic for loop that has an initializer or a local variable called I, and I'm going to set that as 1 because we don't need to worry about counting 0 because that's not going to add any value to our actual overall sum. And then what do I want to continue up to? I want to continue looping until I is greater than or equal to the value provided in num. So essentially what we're doing here is we're going to be counting up one by one from 1, 2, 3, 4 until I is at the value that num has been passed into us. Okay, so to do that incrementation, we can say I plus is equal to 1. And for each time we loop through these numbers, the value of I will obviously increase. So we can just add that onto the sum variable that we created above. So for each loop, I will be added onto the sum. So that'll be 1, 2, 3, 4, and that will continually get updated into the sum variable until the point where it's actually reached the number that's been passed in. And at that point, what we can do, because obviously we need to return something from the function, we can just return the value of sum. So let's check our tests and see how we got on with that. And as you can see, all the tests have passed. The first one, I think, was to add 4 and 13 and 600 like we did in the instructions. So we know they're all passing and all of the other tests have passed too. Great, so that's a good feeling that we've got all our tests passing with our simple function. And to be honest, this is probably a good solution for this actual exercise because it's very readable. We can see exactly what's going to happen when the code runs. But before we complete this challenge, let's just have a look at a way that we could do this using some other JavaScript features. So I'm just going to remove everything that we've got here, and I will convert it to an arrow function as well, which means we can remove those parentheses from there. And I'm going to be doing this all on one line, so I don't need to have the curly braces or the return statement. So one function that's available to us is the JavaScript reduce function, which allows us to loop through an array and then basically reduce the values in the array down to one number. But obviously we don't have an array at the moment because we've just been passed in a number, so we could try and make an array and then reduce that down into the total that we need. So just quickly, I'm just going to open up my developer tools just to go through a couple of things here. So because we don't have an array, we can create a new one with the new keyword, so we get a new empty array. So we don't want an empty array, we want an array that has the number of items that based on the number that's been passed into the function. So we could say the number is actually 4 that's been passed into the addup function. So we could do that and get an empty array which has a length of 4, but we actually need to fill that with some values to actually get items into the array, and the value that we're going to fill it with doesn't really matter, so I'm just going to use a 0, and you'll see why that doesn't matter in just a moment. So now you can see we've got an array of 4 zeros. So now what we can do is use the reduce function, as I mentioned before, and the reduce function takes a callback which has the accumulator as one of its parameters. We also have the item itself, so this will just be 0, 0, 0, 0 on each run of the reduce function. And then also we can access the index of the item in the array, and this is the important value that I want to get out in this function. So again, I'm just going to do an arrow function that has an implicit return, so we don't need the curly braces or return statement here. So each time I'm going to return the accumulator, which will be the sum of the calculation that we're doing, very much like the sum variable that we created in our previous version of the addup function. I'm going to add a value to that on each time, and the value I'm going to add is the index, which will start at 0. So I'm going to add 1 onto that index value each time. So essentially what this value will be on each loop of the reduce function is 1, 2, 3, 4. So this is mimicking the for loop that we had in the previous version of the addup function, but as you can see, it's just using this reduce function instead, and it's working on the array that we've created. So I'm going to initialize the accumulator with a value of 0 so that we don't get any weird results with undefined values there. And if I just run that code quickly, you can see I get the value of 10, which is exactly the value that we get in our test and what we got with our previous function as well. So that's one way that you could solve this, and I can just copy and paste this from my developer tools into the function that we've created here. Let's have a semicolon at the end there, and if we run that again, I don't think there's a way that we can run it. Let's just submit final again, and hopefully if we've got that right, that should pass. Oh no, we've got failures, and that's because I hard-coded the for value in there, so let's just replace that with num. So num is obviously the value that's passed into the function. So the first one passed okay because we had 4 as the parameter. And there we go, we've got all the other tests passing as well now. So personally, I think this solution is really unreadable. Just because you can do it this way doesn't mean you should. It's obviously a bit cleverer than the previous version. But if you found this in a code base, obviously the function name should describe what it's doing, but just looking at that one line of code, it's pretty tricky to work out what's actually happening. So I'll probably advise against this sort of solution, but just as an example of a way that you could solve this using some of the other JavaScript features. Okay, so let's move on to our next challenge, and we're going to go on to this one here, which is Matchstick houses. So this challenge is basically asking you to work out a formula. So it doesn't provide you with the formula, but we're presented with imaginary versions of these matchstick houses. So the first one looks like this. And then when there are 2 matchstick houses, there are this number of matchsticks here. And the function that we're creating is basically saying how many houses are we looking at, and we're passed in that as a parameter to the function. And then we're trying to calculate how many actual matchsticks make up that particular pattern. So this is going to be basically working out the formula that when we reach this stage, how many matchsticks are we actually using? Because you can see for the first one, we're using 1, 2, 3, 4, 5, 6. And then for the next one, because we've already got this wall finished on the matchstick house here, the number of matchsticks isn't 12 because we've actually got this wall completed here already. So if we just quickly count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we need 1 less matchstick because we've got this adjoining wall here. And once we've reached this point here, we're just adding on 5 matchsticks each time. So we've got 1, 2, 3, 4, 5. So we're just going to be adding on 5 more matchsticks for every new house that's being added. So hopefully you've got the hang of that. If you're not quite sure as well, there are some resources here which give you some hints about matchstick patterns as well, so you can take a look at those. But let's crack on with the code. First of all, I'm going to do a really simple solution. And because we're checking the value of the step that's being passed in, I'm actually just going to use some if statements to do this. And I should have pointed out as well, if the step is passed in as 0, so the parameter that's passed in here is 0, then we just return 0. So that will be the first check that I'm going to do. I'm going to say if the step is equal to 0, then all we need to do is return 0. Now we don't need any else statements here, because if this actually is true, the return statement will return this value and the rest of the function will not complete. So we don't need to worry about any else statements here. So if step is equal to 1, how many actual matchsticks do we return? Well, there are 6 here, so let's just return 6. Return 6. And then we're going to check if the step is equal to 2. Well, how many matchsticks have we got here? Well, there's 11 that we counted up before, so we're going to return the value of 11. But any value after that, we're actually going to be in this state here where we're just adding 5 matchsticks on to the value that we had previously. So the previous value that we had is 11, and then we're just going to add on the number of steps multiplied by 5. But if we actually run those tests now, we're going to get a slight problem. You can see the first 2 pass okay, but the rest of these don't. You can see we're actually getting a larger value than we should have done for the first test, for example. And that's because we don't want to consider the first 2 steps, because we've already made provision for those in our 2 if statements. So we're just adding on the number of matchsticks after that. So if we just say, we're going to say, we'll multiply the number of steps that we've got minus 2, and then if we run that again, you can see all of our tests are now passing. We could also put in another if statement here as well and just say something like if step is bigger than 2, for example, and then we can just move this return statement inside of there. But that's not really necessary, because if we've got to this point, then we know step must be bigger than 2 because we've already checked for 0, 1 and 2. But it's up to you whether you want to put that in there for readability or not. Okay, so that's a pretty good solution for this. However, there are quite a lot of if statements like here, and if you find yourself writing functions where you've got little if statements just to check individual values, then that's probably not the best use of JavaScript's features. So you might want to think about another way that you could approach this. So another way is you could use a switch and case statement. So if we could switch on the value of step and then write cases for each of these individual things here. And if you're not sure how that works, have a little search for JavaScript switch and case. And that's one way you could do it. But there's a quicker way that you can actually abbreviate if statements into a single expression. And that's using a ternary operator. And in this case, we're going to do a nested ternary operator. So let's just remove all this code that we've got here for the moment. And again, I'm going to convert this to an array function. And we can remove all of that there. Okay, so on the next line, I'm just going to recreate those checks that we had, but with a ternary operator. So first thing is I'm going to say, is the step value that's been passed in, is that equal to 0? And using the question mark will be the true value. So if that expression is true, what do we want to return? Well, we want to return 0. And then a colon if the expression is false. And I'm just basically going to nest another expression in there. So we're going to say the second if statement that we had is step equal to 1. And if that's true, then we want to return 6. But if it's not, we're going to check if the step is equal to 2. And if it is, then we want to return 11. But if not, then we're just going to use our default return that we had, which is to use the formula that we created. So we're going to return 11 plus the step minus 2, and then multiplied by 5. So here we've just recreated all of those if statements using a nested ternary. And yeah, it doesn't look the best. It's quite difficult to read, but it is a shorter way of writing all those if statements. It's a little bit more difficult to follow through which if statement will be triggered at which value, but it does work and it will give you the same results as we had before. So that's that challenge complete. Let's go back and have a look at some other challenges now. So that one's complete. And as I said at the start of the tutorial, we'd go back and have a look at this bitwise operations exercise here. So although this is an easy exercise, it's a little bit complicated to understand what's going on. And you need to have a little bit of an understanding of computer science in terms of how binary works. But essentially, you've been asked to create 3 functions this time to do something called bitwise AND, bitwise OR, and bitwise exclusive OR. So what we're going to be given in these functions is 2 decimal or integer numbers, so here 6 and 23, and essentially we're going to convert those into binary strings, and also then, if it's the AND function, for example, we're going to go through each of those actual numbers and check if they exist in both strings at the same position, and if they do, we're going to return a 1 or a 0 depending on which function we're looking at. So I'm not going to go into too much more detail about bitwise itself, but I think there's some resources down here about bitwise operation. The JavaScript language actually does give us some bitwise operators as well, so we could technically just use those, but the actual challenge itself is asking us to create our own functions to do this. Okay, so let's go over to the code and start writing some functions here. So I'm just going to focus on this bitwise AND function for the moment, and then we'll go back and fill out the OR and exclusive OR in just a second. So the first thing I'm going to do with these arguments that are passed in, I'm actually going to convert them into a bit string. So basically taking that number here and converting it into a string like this. So to do that, I'm going to create a new variable, and I'm going to call the first one n1 bits, for example. And to actually make the conversion, there's some instructions to do this in the challenge. I'm going to call the toString function on the n1 variable and then pass in the value of 2, which will actually convert this into a binary string. So just to show you what this looks like on the console, let's say we have a variable of n1 and it's going to have a value of 26. If I then say n1 toString, and then pass in that value of 2, you can see this is the string result that I get back. But there's a slight problem with this as well, because if we have a small and a large number come through, so say we've got n2 and the value is 3, if I then say n2.toString, I'm passing the value of 2, you can see this gives me the right result, but the string is a lot shorter than the value that came back for n1. And we really need the strings to be the same length because we're going to be examining the values at each position and comparing them. So we need to get these strings to be the same length of characters. So there is a function that we can use to do that, and it's called padStart. And what padStart does, it takes 2 arguments itself, and we say how long do we want the string to be, and if the string is shorter than that, then what do we actually fill the empty spaces with. So I'm going to make sure all of our strings are 8 characters long, and if there are any empty values, as there are with the n2 string, I'm going to fill them with zeros because that won't affect the result of our binary string. So you can see now our n2 string looks like this, and if I do the same thing for our n1 string, you can see they're of equal length and we've got the correct binary implementation, and we can easily compare the values at each position. So let's do that into our code that we've got running in our challenge. So we'll say padStart and 8 and 0. And I can literally just copy and paste this for the second parameter. So we'll say n2 bits is equal to n2.toString. Okay, so with that conversion done, we can now start working on comparing those values. And I'm going to store the result into a new array. So essentially I'm going to be building up a new array with a comparison of the 2 strings, and you'll see how that looks in just a moment. But what I'm going to do for the main process is to actually just loop through each of the items in the actual string. And you can't necessarily do that without converting the string to an array straight away. But we can access each item in the string via its index position using a square bracket notation. So I'm just going to set up a loop that's going to basically loop for the length of n bits. It should be 8, but just in case we want to change anything in the future, this will just make our code a bit more future-proof. So n1 bits is a string, and we'll just access its length property, just see how long it is. And then what we're going to do is just iterate through one step at a time. And in here, I'm just going to do a quick comparison using an if statement. And I'm going to say for n1 bits, so this is the string. So I'm going to access the string at position I. So starting at the first position in the string. And I'm basically going to say, is that equal to 1? And if it is, I also want to check if the n2 bits at the same position is also equal to 1. So the purpose of an AND operator is to basically check if both bits in the same position are both equal to 1. So this if statement will achieve that. So if that's the case, I'm just going to say, well, the result array that I'm working on, the result at position I, I'm just going to set that to 1. But if it's not, if that if statement fails, I want to then set the result of I equal to 0. Okay, so I need to return the result from the function when it's completed, but I don't want to return an array, I want to actually return a string. So I'm going to join that all together as one string. But if we actually run those tests now, you'll see we'll get some failures. Okay, and some of these are for the functions that we haven't yet implemented, but you can see here we're returning the binary string, but the function actually wants the decimal value itself, the integer that this represents. So we can call another JavaScript function, which is parseInt, which will actually return this string as a decimal number, but we actually need to tell it what type of number it is. So if you pass it in the number of 2, so it's base 2, the parseInt function will know that this string that's coming in is binary. And if we check another time, we can see that the tests that at least are using the AND, bitwise AND function are actually passing now. So that is one possible solution for the bitwise AND function. Before we move on to the other two functions, I'm just going to do some refactoring around this. I won't actually convert this to an arrow function this time, just to keep the structure of the challenge intact. But what I am going to do is create an additional function, because we're actually going to reuse this in our other functions that we're going to be working on. So I'm going to create a function called convert number to bits, and it's basically going to take in a number value. So we'll just say that's variable's called n. Actually, let's call it num. And what I'm actually going to do is reuse this functionality that we've created here. So I'm going to say, for the number that's passed into that function, convert it to a binary string and then pad it to 8 characters with leading zeros. So what that means is we can actually reuse this function here. So we can, instead of using the code that we've already got here, we'll say convert number to bits, and we want to pass in n1. And then also here, we're going to convert numbers to bits, n2. So what we can then do for our other functions, we can just grab that bit of code there with using our new function that we've created, and we can just pop that in there and in here. Let's just align that a little bit better. And then if at any point we want to change how the padding is done or how the representation of bits is presented, we can just come up here and change this one function. So the other bit of refactoring I'm going to do in the bitwise AND function is to actually make this if statement a little bit neater. So what we could do is convert it into a ternary rather than having the if and else statements there. So I'm going to say the result of I, which is our result that we're returning, is equal to the same expression, and if it's true, we'll return 1, if not, we'll return 0 and store that into our array. We can just wrap this, not necessary, but we can wrap this in parentheses as well, just to make it a little bit clearer as to what the expression is that we're checking. And with that in place, if we just run the checks again, you can see the tests that were passing before are still passing, and we've made our bitwise AND function a lot more readable. Okay, so for the bitwise OR function, we'll move on to that next. We can literally just copy and paste the function again for bitwise AND and just make a tweak. But this time, instead of an AND, we're going to be doing an OR. So basically we're saying in our strings that we're comparing, if either one of the numbers at a certain position is equal to 1, then we're going to return 1. But if both are equal to 0, then we're going to return a 0. So this should be all we need to do for our bitwise OR function. So we've already got our existing code to convert the number to bits, and we've just copied and pasted the code for looping through the actual strings themselves. And you can see now we've got a lot more tests passing. It's just the ones for the bitwise exclusive OR that aren't passing at the moment because we're still getting undefined. But you can see how we've reused code from our other functions to make life a bit easier for ourselves. But let's just finish off the challenge by completing the bitwise exclusive OR function. So this is a little bit trickier, but we can just get the boilerplate code from the other function just to help us out, start us off with this solution. And I'm just going to remove this from here. So we're still going to have an if statement here, but we're going to be making a bit more of a complex expression. So for an exclusive OR, and again, there's some information about this in the resources, basically we're doing the same thing as we would do with an OR, checking if one or other of the items in the string are actually a 1. But if both the values are actually 1, then we should return a 0. So it's like saying only one of the values can be 1, but if they're both 1, then it should return a 0. So that's what we need to recreate in our expression here. So in n1 bits at position I, we're going to say if that's equal to a value of 1, or n2 bits at position I is equal to 1. But we need to do that further check to make sure that they're both not set to 1. So we're going to negate this expression here that we're going to create. So if we're saying if not, n1 bits at position I is equal to 1, and n2 bits at position I is equal to 1. So it's a bit hard to see they're all on one line, but essentially we're saying either n1 bits or n2 bits needs to have a value of 1, but if they're both the same, then this if statement will fail. So if it is true, we want to set the result value at a value of 1, but if not, we want to set it to a value of 0. And just check we've got our return statement in there, which we have. So let's just check those again. And this time you can see that everything passes, and we've got implementations for all of our functions, and they seem to be returning the right results for each of the test cases. So there's a bit more work in this challenge, but as you can see, you've got the opportunity to actually create your own functions and to reuse code in different parts. And hopefully by following through my solution here, you've learned a couple of things about converting decimal numbers to binary, and also this really useful pad start function to actually fill any missing or leading spaces with a particular value. So that's pretty much it for this tutorial. We will be moving on and looking at some more intermediate or medium challenges in the next few videos. So don't forget to subscribe so you don't miss out on any of those. And if you have any questions about the challenges in this video, just drop a comment below. And let me know if you came up with any different solutions. It'd be good to see how you approach these challenges. But that's it for this tutorial. I'll see you next time.